In a galaxy 9 billion light years away, a star is dying tonight. It is one of the very first generation, and it has already been dead for more than 90% of cosmic history. By the time its light reaches Earth, thousands of new generations of stars will already have come and gone, and right now that ancient death signal is somewhere in the dark, racing toward us at the speed of light. If you are the kind of person who likes real space stories without the cheap cosmic hype, tap subscribe right now. We follow the science, not the rumor mill, and we are about to walk into one of the strangest chapters of the entire universe together. To understand what killed the first stars, we have to wind the cosmic clock all the way back, right back to before there were galaxies, right back to before there was anything you could see with your eyes. The Big Bang had already happened. That was the moment when all of space, all of time, and almost all of the energy and matter in the universe burst out from one unimaginably tiny point. For a long moment, the whole universe was a hot, bright soup of energy, hotter than the center of any star we know today. Then things started to cool down. As the universe cooled, something amazing and simple happened. Particles of matter formed, mostly hydrogen, the lightest and simplest gas in existence. Next came helium, the second simplest gas. And then, in almost too small amounts to mention, traces of lithium and beryllium appeared. That was it. That was the entire list of ingredients the universe had at that moment. Just hydrogen, helium, and the faintest dusting of two more. And here's a fact people often overlook. By weight, the universe was about 75% hydrogen and about 25% helium, with only a tiny fraction of anything else. That ratio is not a guess. It is the result of a process scientists call Big Bang nucleosynthesis. It has been measured again and again, and it stays the same. Roughly 3/4 hydrogen, 1/4 helium, and a sliver of everything else. No oxygen yet, no carbon yet, no iron, calcium, or silicon yet. Nothing heavier than helium existed anywhere in the entire universe at that point. It was a clean, simple, almost empty place. And it was dark. There was no starlight yet. There was no moonlight. There was no glow of galaxies on the horizon. Cosmologists, the scientists who study the shape and history of the universe, call this long stretch of time the cosmic dark ages. It sounds poetic, but it is also literally true. The lights had not yet been turned on. For hundreds of millions of years after the Big Bang, the universe was simply waiting. Slowly, gravity started to pull little pockets of this gas together. Gravity is the same force that keeps your feet on the floor and the moon circling the Earth. Out in space, gravity pulled drifting hydrogen and helium into denser and denser clumps. When gas gets denser, it gets hotter. This is the same reason air gets warm when you squeeze it with a pump. So these clumps of gas got hotter and hotter as they shrank. Eventually, they got so hot and so squeezed and so tight that they lit up. The very first stars were born. Scientists call these the population 3 stars. The Roman numeral 3 is just a label. Pop 1 and Pop 2 are the stars that came later, including our own sun. Population 3 means the very first generation. They were number 1 on the list, the founders, the original lights of the cosmos. There were no stars before them ever. Now, here is something important that often gets skipped in popular videos. These first stars were not anything like what we see today. They were made of clean, almost pure gas. They had no metals inside them, and in astronomy, metal does not mean iron or gold the way it does in everyday talk. In astronomy, metal means anything heavier than helium. So our sun has metals in it. Every star we see in the night sky has metals, but these very first ones did not. Scientists call this condition pristine, a word that here means untouched, pure, original. They were built from the simplest possible recipe the universe had. Now here is the big mystery that drives this whole story, and it is where most people guess wrong the first time they hear it. If these first stars were made of the simplest, cleanest, smallest ingredient recipe in the universe, you might expect them to be calm, gentle, and long-lived, the way a small candle burns slowly. That is the natural guess. That is the assumption most of us make when we see stars in our own sky, and we picture them as calm, steady, patient points of light. So we naturally picture the first stars the same way. A tiny star like a red dwarf, low mass, simple gas, can live for hundreds of billions of years. The smallest, slowest burning stars we know of should also be the cleanest. So intuition says the first stars should have been the calmest, the longest lived, the gentlest. But the universe does not always play by our expectations. The very first stars were almost all massive. We are talking many, many times heavier than our sun. Some of them may have been 100 times the mass of our sun. Some may have been 200 times. Some may have been even heavier than that. And the rule for stars is very simple and very important to remember. The bigger the star, the shorter the life. A star 200 times our sun's mass does not live long. It burns through its fuel like a match lit in a hurricane. A star like our sun is like a slow burning log in a campfire. A star 200 times our sun's mass is like a bright flash of powder, quick, fierce, and over. So instead of living for billions of years the way our sun does, these first stars lived for maybe 1,000,000 years. Some of them lived for only a few 100,000 years. That is a tiny, tiny moment in the life of the universe. Billions of years is to millions of years what a human lifetime is to a single blink. They came into being, burned incredibly hot, and then died very fast. The universe was still almost brand new when the first generation of stars was already gone. A few 100 million years, that is roughly how long the very first stars had to live and shine. The universe is currently about 13.8 billion years old, so the first generation of stars lived for less than 3% of cosmic history before they were already gone. And their lives were shockingly short compared to expectations, calm and gentle they were not. What is next is the part most people remember most from the science, because the way these stars died was not the way stars die today. Now, scientists think there were two main ways the very first stars met their end. The first way is called a core collapse supernova. This is what most big stars do today, and it is what most big stars did back then too. A star is basically a giant balancing act. The outer layers of the star are constantly being pulled inward by gravity. The core of the star, where it burns fuel, is constantly pushing outward with energy. As long as those two forces are matched, the star stays in shape, it stays the same size, it shines, but at the end of its life, the core runs out of fuel. The energy pushing outward runs out, gravity wins, the core, the dense middle of the star, suddenly gives up and collapses on itself. This collapse happens in about 1 second. Imagine the floor dropping out from under a building. In that single second, the temperature inside the core climbs unbelievably high, past billions of degrees. Then the outer layers of the star come crashing inward so fast that they smash into the core and bounce off it. That bounce sends a shock wave ripping back outward through the star, tearing it apart in one enormous explosion. A core collapse supernova is one of the most violent events the universe ever produces. For a few weeks, a single exploding star can shine brighter than an entire galaxy of hundreds of billions of normal stars. It blasts heavy elements like oxygen, carbon, silicon, and iron into space. It is, in a real way, the engine that builds the chemistry of everything we see today. Without these explosions, planets would never form. Without planets, life would never begin. So even though these deaths look like destruction, they are really creation in disguise. For a long time, scientists thought this is how the first stars died too. Big stars, fast lives, core collapse, big explosions. That story fit the early models and made sense to everyone. Then something much stranger showed up in the math. But here's the twist scientists have been uncovering for the past few years. Some of the very first stars were so massive, so huge, so different from anything we see today, that they did not explode the normal way at all. They exploded in a completely different kind of death, one that almost no stars in our modern sky can even have. And now we have to ask, before the reveal, did you know our sun is already middle-aged? Do you think it will end the way these ancient giants did, or die more quietly? Drop your guess in the comments below, and while you are there, hit like so we can keep making stories like this one. The second way these first stars died is called a pair-instability supernova. The name sounds strange, but the idea is simple once you hear it. When a star gets truly massive, around 130 to 250 times the mass of our sun, its core gets so hot that something weird starts to happen. Heat inside the star is normally carried by light, by tiny packets of energy called photons, and these photons push outward against gravity and help hold the star up. Very hot photons in a very hot star, very simple to picture. But at extreme temperatures, those photons start to do something strange. They collide with each other and turn into pairs of particles. In physics, we call these electron-positron pairs. The photon used to hold the star up. The pair of particles does not, so the star suddenly loses part of its support system. Gravity wins, and the core of the star begins to collapse. But then, instead of collapsing into a small dense ball like a black hole, the falling material gets so hot and so dense that nuclear fusion lights up the entire star at once. And this is the key part that makes this kind of explosion so different. The whole star goes up, not just the outer layers, not just one side. The entire star, every piece of it, blows itself apart in one glorious, complete explosion. Nothing is left behind, no black hole, no neutron star, just a bright flash and a huge cloud of new elements scattered into space. A pair-instability supernova is so powerful that it can shine brighter than almost anything else in the early universe. And here is the strange, beautiful part. These explosions did not just kill the star, they also cooked up the very first heavy elements in the universe, the oxygen you breathe, the calcium in your bones, the iron in your blood. All of it may have started inside one of these first giant stars. They were made, used, and scattered by stars that no longer exist anywhere in the sky. This is the reason why astronomers have been hunting for evidence of pair-instability supernovae for years. In 2023, a team led by researcher Q.F. Ching published a study in the famous science journal Nature showing chemical traces in an old metal-poor star right here in our own Milky Way galaxy that match what a pair-instability supernova would have produced. They found a strange chemical pattern, much more silver than expected, and a very unusual mix of other heavy elements, exactly the fingerprint a giant ancient explosion would leave behind. That single star we can still see today is like a chemical fingerprint from a star that died 13 billion years ago. We are reading its old diary entries through the atoms it left behind. So the first stars did not just live and die quietly. They blew up in ways that were far bigger, far hotter, and far more important than almost any star we see today. And they were very, very short-lived. Today, most stars in our sky will outlive human civilization. Our sun has about 5 billion years left. The first stars barely outlasted the time it takes light to travel across a small piece of the Milky Way. But the deepest secret about them, the one scientists are only now beginning to understand, is something we are watching in real time. And this is the part that makes this story feel like it is still happening right now. In December 2021, NASA launched the James Webb Space Telescope into space. It was sent about 1 million miles from Earth to a special point in space called the second Lagrange point, where gravity from the sun and Earth work together to keep it in a stable spot. From there, it can look deep into the universe with almost no interfering light from our planet. The James Webb, often shortened to JWST, is the most powerful space telescope ever built. It has a main mirror about 6.5 meters across, more than 2.5 times larger than the older Hubble Space Telescope, and it was designed in part to do one main job that we could never do from the ground, to look back in time, past almost everything, all the way to the very first stars and the very first galaxies. How does a telescope look back in time? Light travels, it moves at a fixed speed, the speed of light, which is about 300,000 kilometers every second. Light takes time to move from one place to another. Sunlight takes about 8 minutes to reach us, so when we look at the sun, we are actually seeing it as it was 8 minutes ago. The light from distant galaxies took billions of years to reach us, so when James Webb looks at very distant galaxies, it is literally seeing them as they were when the universe was young. In the years since launch, James Webb has done something no one fully expected. It has spotted galaxies that already look fully grown when the universe was only about 300 million years old. That number matters, and it is genuinely shocking. 300 million years sounds big to us, but compared to the 13.8 billion year age of the universe, that is just the blink of an eye. Imagine baking a cake and finding it already fully decorated just 1 minute after you put it in the oven. How could big, bright, organized galaxies exist so soon? One answer hiding inside that question is that the first stars were larger, hotter, and more violent than the old models predicted. They were not little quiet stars gently twinkling. They were bright, fierce giants that poured out huge amounts of light very fast. James Webb is now showing us this directly. It is seeing what the very first starlight actually looked like, and it is brighter, hotter, and more powerful than anyone fully modeled before the year 2022. Now here's a question with no easy answer. What do you think came first, the first star or the first galaxy? Drop a quick comment with your guess, and if you do not want to miss the next chapter, tap subscribe right now and join us along the way. Along with those early galaxies, James Webb has also spotted something truly strange, tiny bright red dots in deep space. Scientists nicknamed them little red dots. At first, no one knew what they were. They were too bright to be normal galaxies. They were too compact to be normal star clusters. Some people thought they might be very old stars. Some thought they might be baby black holes. Some thought they might just be ordinary galaxies hidden by thick clouds of dust. But in 2024, a team at the Center for Astrophysics, known as the CFA, located at Harvard and the Smithsonian Institution, working with scientists around the world, put forward a striking new idea. What if these little red dots are not galaxies at all, but the glowing surfaces of supermassive stars? Not little stars, but giant ones, hundreds of times the mass of our sun, floating quietly in the early universe, burning bright and red because they are so huge. If this is true, we are watching a second generation of population 3-like stars in their final moments. We are seeing dying giants from across billions of years of time, and if even one of those little red dots really is a single supermassive star, it changes how we picture the early universe. It means the first stars may not have been lonely, scattered, rare points of light. They may have been packed close together in groups, shining so bright they made entire regions of space glow red. And this is a discovery that did not exist a few years ago, and it is still developing today as James Webb collects more data. Every new image that comes down from the telescope gives scientists another clue, and every few months a new paper changes the picture a little, and there is more. The James Webb Telescope has now seen galaxies that hold the current distance record. In 2024 and 2025, scientists confirmed a galaxy called JADES-GS-Z14-0 at a redshift of 14.32. In simple words, that means the light we are seeing from it left when the universe was only about 290 million years old. Light from that galaxy has been traveling toward us for over 13 billion years, and it is only just arriving today. The moment we look at it through James Webb is literally the moment its ancient light reaches our eyes for the very first time. That redshift number deserves a quick explanation too. Redshift is a tool astronomers use. The farther away a galaxy is, the faster it is moving away from us, and the more its light gets stretched. As light stretches, it shifts toward the red end of the color spectrum, the way a siren's pitch drops as the siren drives away from you. So a redshift of 14 means the universe has stretched that much compared to the light the galaxy gave off. That is a staggering amount of stretching. It is the strongest evidence we have of how much the universe has grown since the early days. So even though the first stars died 13 billion years ago, we are still receiving their last light right now. We are still seeing the afterglow of their explosions. Every time James Webb points at a new patch of sky, it is collecting photons that left those first stars when the universe was an infant. They have been flying through empty space since before the Earth even formed, and we are the first eyes to ever greet them. There is another small clue we should not forget. Some of the oldest stars we can still see today in our own galaxy, like the famous Methuselah star, catalog number HD 140283, about 200 light years from Earth, are almost as old as the universe itself. Their metal content is 250 times lower than our sun's. That makes them the closest living relatives of the first generation we will probably ever meet. They are survivors who have kept the chemistry of the early universe in their bones. Now zoom out with me for a moment. Why does any of this matter? Why should anyone, especially someone watching a quiet video late at night, care about stars that died before our planet even existed? Here is why. We are made from their leftovers. Every atom of carbon in your body was made inside a star. Every atom of oxygen you breathe was made inside a star. Every atom of iron that carries oxygen in your blood was made inside a star that exploded. The calcium in your bones came from a giant that blew up before the sun was even born. The gold in jewelry, the silver in old coins, the iodine in your salt, all of it came from ancient stellar explosions. We are not made from dust by accident. We are made from star ash. The first stars were the universe's first great experiment. They tried something new with almost nothing. They burned clean hydrogen and helium with no other ingredients mixed in. They failed quickly. They exploded hard, and by exploding, they made the universe richer. They seeded the dark, empty space with the first heavy elements. Without them, there would be no rocky planets, no water and oceans, no air to breathe, no life. Without those first violent deaths, we would not even exist. So when we ask what killed the first stars, we are also asking how everything we know came to be. Their short, violent lives were not a tragedy. They were a gift. They burned, they died, and their ashes became the raw material for galaxies, for planets, for oceans, for trees, for animals, for us. The whole universe we see today is the second draft, written in the ruins of the first one. We live in the afterglow. What is even more humbling is that the universe also seems to have a hidden pattern here. The slow, gentle stars that come after the first ones, stars like our sun, are made from the ashes of the short, violent ones. So the calm, friendly stars that grow planets and give us decades of steady light are only possible because the very first stars were so unrestrainably fierce. Patience was born out of impatience. Stability was made possible by chaos. The steady sky we look up to tonight is a quiet child born from noisy parents. And here's the part that should make you feel a small chill. This is not a finished story. Scientists are still finding new clues. James Webb is still scanning the sky. The Harvard team studying little red dots is still publishing papers. New telescopes are being planned to look even further back, including a concept called the Habitable Worlds Observatory, NASA's next flagship mission, which will build on Webb's success and one day try to spot the first galaxies in even sharper detail. We may in our lifetimes see the actual light of a star exploding in a way that has not been seen in billions of years. We may even spot a place where the very first star was born. The mystery is alive, and we are alive inside it. We are standing in a very strange moment in science. For thousands of years, humans looked up at the stars and wondered what they were made of. We did not know. We made myths. We drew pictures on cave walls. We built towers. And then, only in the last 100 years, we figured out that stars are mostly hydrogen and helium, and that heavier elements are made inside them through nuclear fusion and violent explosions. And now, in just the last few years, we have begun to see the very first ones directly, and to understand that their deaths built everything we are made of. This is one of the greatest stories in science, and we are inside it right now. Think about that for a moment. The atoms in your body are 13 billion years old. The hydrogen they came from was made in the Big Bang. The heavier atoms inside you were made inside giant stars we will never see. The stars that made them died before our sun was born. And yet here you are, watching this story on a planet made from those ashes, using those atoms to think about where they came from. We are the universe becoming aware of itself, and we are doing it in real time. So what should you do with all of this? If this video made you think about how the universe is put together, share it with one friend who would love this kind of story. Send it to someone who always stares up at the night sky. Send it to the friend who asks big questions and never gets a satisfying answer. And if you have not already, hit that subscribe button and turn on the notification bell, because the next discoveries from James Webb are already on the way, and we will be here to walk through them one by one as they happen. Thank you so much for watching all the way to the end of this story. Until next time, keep looking up.